Obtain the mesh file and also the full training movie by purchasing this product. The present issue concerns the simulation of airflow around a NACA 0015 airfoil. This airfoil is a symmetrical airfoil that doesn't produce a lift force at zero attack angle. And we investigate the lift coefficient of this airfoil at different attack angles with and without magnetic or MHD force. In this problem, we study the separation and the maximum angle of attack where the separation doesn't occur. By applying the magnetic force or MHD, the separation happens at the larger angle of attack. The present two-dimensional modeling is done by Design Modeler software. The coordinates of the airfoil points are imported in the software, and the solution domain is a circle of 10 to 12 times of the radius of the airfoil chord. To solve this problem, after defining the domain, an unstructured triangular mesh has been applied around the airfoil. For the boundary layer flow, applying finer meshing, which departs from airfoil, is gradually getting bigger in order to make it easier to solve and reduce the computational time. By checking the cell zone condition, we can check that the material in the domain is air. A source term in the term of X momentum is activated. In this CFD simulation, we divide airfoil body to the bottom wall and the upper wall, and both have the same boundary condition. The wall motion is stationary and the shear stress condition is no slip for both. You can use the residual monitors dialog box to control the residual information that Fluent software reports. In the equations section, the residual option indicates the name of each variable for which residual information is available. And the monitor indicates whether or not the residuals for each variable are to be monitored. You can toggle monitoring on and off for each variable by turning the corresponding checkbox in the monitor list on or off. The check convergence option indicates whether or not the convergence of each variable is to be monitored. If convergence is being monitored, the solution will stop automatically when each variable meets its specified convergence criterion. You can check convergence only for variables for which you are monitoring residuals. You can toggle convergence checking on and off for each variable by turning the corresponding checkbox in the check convergent list on or off. And finally, the absolute criteria or relative criteria shows the residual value for which the solution of each variable will be considered to be converged. To set this value manually, enter the new value in the corresponding absolute criteria field. And that's it. The initialization solution method is equal to the standard initialization in this case, and also the x velocity and y velocity are computed from the inlet. Via the solution XY plot section, we can plot every desired axis function and variables in every desired position. For example, we are going to plot the pressure coefficients in both bottom wall and the upper wall, and you can see the result. Also, by following this path, we can check and calculate the drag force and coefficient, and also lift force and coefficient in the bottom and upper wall. This table is a summary of the steps for defining the problem and its solution as a review. Obtain the mesh file and also the full training movie by purchasing this product. To benefit from Master CFD services including simulation, consultation, and training, contact our experts via info@mastercfd.com. Hope you enjoy.